Hello. Today we're going to talk something about what is called light. Okay. Okay. So light or visible light is electromagnetic radiation. In physics, the main source of natural light on Earth is the sun. Okay. So this is the basic definition of what is light. So light or visible light is electromagnetic radiation. So it has got both electro and magnetic radiation kind of thing. Okay. So last time we saw something about electrical circuits. Okay. What are the basic elements of electrical circuits? You have a switch kind of thing which is done by kind of like transistors, diodes and things like that. Then after that we saw something to do with inductor, capacitor. Okay, inductor, capacitor and resistor. Resistor is something which is going to completely totally kind of reduce the current or the voltage if you connect it on either end. Okay, so if you connect one side and another side, and it is going to just completely inhibit the flow of current, whether it is AC or DC or anything. So resistor is a kind of thing which is not going to allow, it is going to just shatter the kind of thing. So that is a kind of thing. So it is not going to allow too much of current to pass through. So some current will pass through and it is just going to come in. Okay, that's all. So when you look at light, I wanted to show you how a light looks like. Okay, so usually people don't know how a light looks like. Okay, so I want to show you how a light looks like. So let's look into this. Usually a light wave looks like this. Okay, so don't think that light is something going on a straight line or something like that. Okay, any wave pattern, anything, whether you do with electricity or you do with electricity or any kind of water waves or sound waves, all these things move like this only. Okay, so if you see it in real time, they'll have a look like this. Even light moves like this. So see the thing, it is a kind of some kind of it's a kind of web kind of thing that is going on. Okay, so most of the things are like this. Okay, they make an amplitude on one direction, there's another amplitude on another direction, and two of the waves they merge together. So there are the light ones are the light ones of the wave or the all the magnetic field, which is kind of like going down, and the lighter ones are the electric field. Okay, so the electric field and the magnetic field, they just interpret like this. Okay, wherever it goes. So this is the kind of standard kind of wave model, any kind of thing that is going to go, whether you're using it in your kind of any kind of circuits or anything like that. This is the kind of thing that wave travels. Okay, so what happens is, here also we have what is called a capacitance and inductance. Why this kind of wave kind of thing is there even for light? So it has got some kind of when you flow or kind of wave transmits through a medium, then it will have two effects. One is the inductive effect and another one is uh, 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 what is the capacitor kind of effect. Another one is the other one is the resistive kind of effect. Okay, so when these three combines, when a wave travels, then these three combines, they form what is the called as shape like this. Okay, now you might ask how light has so many different kinds of colors and all coming in. So if we take this kind of model or something like that, this kind of light, and you're trying to interfere with another one, another light wave is coming like this, and the wave patterns they merge like this. Okay, two of the wave patterns they merge like this and give what is called a spectrum. So that is why you get blue light, green light, and other things. Depends on how the things are, the amplitude modulation, phase modulation happen. Okay, so there are two things that will happen. One is amplitude modulation, another one is phase modulation. Those two things will happen when you put two light waves together. Okay, or closer kind of thing. Then you have the interference pattern and all. So it's a kind of like because of the interference, or what is it, it's a kind of inductive kind of thing, then it is going to wrap up extra things. Okay, So there are two effects. What is the capacitive effect and inductive effect and resistive effect? Effect depends on the medium. Okay, usually when light travels like this, if there is a resistor, it is going to completely stop the light. Okay, resistor is something like that in case of electricity. Okay, and allow only minimum kind of thing. Okay, so this minimum, when light goes through a particular kind of sheet or something like that, it's something called quantum tunneling which happens. Okay, only part of the light will go through. That is something to do with resistance kind of thing. Some of the thing gets reflected. It's a kind of inductor, so it is going to be just going in, and then the light is going to just reflect and go off. And all the other effects are something to do with induction, inductive effect of that is the magnetic field, and the electric field merge is going to change. And what that is why we have interference patterns. Then you have color patterns also. Colors, when two color light has got color also because of that. It is not just that light holds that particular kind of color, it is how the frequency is reduced for that. Okay, so the sense that if there is a reduction in frequency, then it is going to have that kind of effect. Okay, so because it has to go through the particular media or whatever, the empty space or whatever, so when two things are going to go in, they interfere with the actual media and produce some kind of color effect. Okay, so these are the, so actually any energy level, or so you say water waves. Okay, water waves, when they look outside, they look like almost like in a circular kind of wave. Okay, when you drop something on a pond or something, they look circular, but actually the wave is traveling somewhat like this. It has got a three-dimensional kind of spin and going. Okay, so don't think that actually the waves that are created in sea and other things are going to be uniform or something like that. Even for a even for light, if it is happening like this, then all other kind of wave patterns that is available, whether it is sound wave pattern or other things. Okay, but in case of if we drop something in the water, there's going to be a circular kind of thing that is traveling. Okay, actually the wave is actually going in one direction. Okay, but what happens is the media doesn't allow those things because it's got high kind of induction. Okay, inductive effect. That is why they spread out. Okay, the wave spreads out. It depends on the kind of media, so the induction effect is extremely high. So what happens is the wave is not able to go up straight or something like that, and what happens is they produce what are called secondary kind of fringes, and that is why you see circular kind of thing, and then going out on different directions and other things. Okay, even light will take different directions. If it is going to pass through some of the media, some special media, then it is going to do what is called diversion. Okay, so it is going to divert the thing and go. Okay, the amplitude is for if you have higher amplitude, the induction effect is extremely high. Okay, so even if a capacitors and other things, so high voltage lines, if we use too much of inductive effect, then it will have completely, they'll just transfer like a transformer. It will go from one coil to the other coil completely, just tunnel through without even anything. Okay, so if they have the right kind of coil, so it's somewhat like that, similar to that. Okay, that is how they, even light is like that. Okay, so they have inductive effect also. Light has inductive effect because of the inductive effect. Only because of the inductive effect, you are able to see the colors of the different colors of light. Okay, now when you see the thing, it is somewhat kind of net pattern. Okay, what is the net pattern? Some kind of parallel kind of links, and it is going up and kind of thing. Okay, so it is just some kind of fabric spinning. Okay, those kind of things. So this is how the light travels in media when we took a look at it. Okay, so anyway, let's go back. So that is where we wanted to look at the thing. So here you see this is the kind of interference pattern that is happening. Okay, so actually there we see a single light coming in. So this is the kind of light that is coming in, and if it is going to go through some kind of media or something where it is going to be interfering with the some kind of that sheet like thing is going to interfere, or diffract. So this diffract, it's a kind of interference kind of thing which is going to create this kind of color kind of sheets. Okay, that is why you get a color like this: blue to green, green to yellow, yellow to red, and things like that. Okay, so So this is just a understanding of how light works, how a LCR circuit works. LCR circuit is also the same thing. Okay, you're trying to do the flow of current. Okay, current, the vibration of the electrons within the current. Okay, here the vibrations are within the light photons itself is some kind of vibrating element. Okay, so that is why you're just jittering the whole thing. And even photon doesn't travel and all. Okay, people usually say everything this is just an energy transmission, which means that the wave is just, kind of like if you take a string and then whip it, then it is going to go through the other end. The only the uh, you cannot send something over the thing. So if you're putting something over that, you can go. But it is not anything. Wave is something to do with kind of uh, just the energy transmission going in one side, not the entire electrons are going, or the entire photons are going on the other side. Those kind of things are not there. Even for photon, the entire photon doesn't go on the side. It just jitters the medium and goes. Okay, for any kind of, but they have different kinds of frequencies depending on what kind of thing. So light or visible light is an electromagnetic radiation that can be perceived by human eye. Visible light is usually defined as having wavelengths in the range of 400 to 700 nanometers, corresponding to the frequency of 750 to 420 terahertz. So frequencies for light is almost like terahertz between the infrared with longer wavelengths and ultraviolet shorter wavelengths. So infrared is going to have shorter wavelengths and ultraviolet is going to have higher wavelengths. Okay, so they are going at speeds of almost like terahertz. Okay, the frequency is extremely high, and nanometers, they are at the level of 400 nanometers. So if we take a photon or something like that, it's going to be one single swing of the whole thing. The last time we saw whatever how the light curves. So that one photon kind of thing, it's going to have around 400 nanometers. So that is the thing. Okay, so infrared, ultraviolet are all inductive and capacitive effects of the circuit. Okay, and resistive effect is almost like you just tunnel through some of the light. Just takes. It's a kind of not a mirror or a glass effect. Okay, so those are all tunnel theory effect. Okay, because it's a high speed kind of thing. The wave is transmitted. The energy is transmitted. High wave they can tunnel through. That is why you see glass like thing, light going in a glass like thing. In physics, so the media depends on how it affects the thing. So there are three different effects that can have. One is a resistive effect, then you can have an inductive effect, then you have a capacitor kind of effect. Okay, capacitor kind of effect is just hold the electricity. And if the capacitor effect for light kind of thing is electron getting absorbed, I mean light getting absorbed to some other trapped in media kind of thing. Okay, so we can use for as a capacitor circuit, inductor circuit, and resistor circuit, but depends on what kind of things you choose and how to affect it. In physics, the term light may refer more broadly to electromagnetic radiation of any wavelength, whether visible or not. In the sense, gamma rays, X-rays, microwaves, and radio waves are also light. The primary properties of light are intensity, propagation, direction, frequency, or wavelength spectrum, and polarization. Speed in a vacuum is around uh, how much 300 lakhs meters a second. Okay, is one of the fundamental constants of nature, or something to do with 3 million or 3 billion kind of speed. Okay, called for the reference to the quanta of electromagnetic field is propagated by massless elementary. It says it's got no mass and all. It is any wave has got kind of like mass. It doesn't have, actually it just jitters the medium and goes. Okay, so any kind of mass transmission is something to do with jittering of the medium. So even if we take planets and the planets are moving from one direction to another, it is actually the wave that are making this. So even planets move like what I showed you right now. The kind of the shot I showed you, the wave, how it looks like. So even the planets move around the sun like somewhat like this one day. Okay, so don't think that it is moving in a regular kind of, but the center of gravity is almost like the line. Okay, the center line, the axle line. So most of the things are like that. Any way kind of wave, whether it is a nuclear blast or something like that. It's going to go like that. Fire, kerosene lamps, electric lights, power system, and things like that. Speed of light is because it's extremely high speed, and secondly the frequency is extremely high, and it's extremely short wave, extremely reduced kind of wavelength. That is why light can just pierce through most of the media. Okay, that is why it is going through, it gets reflected, it gets pierced through some of the glasses and other things. It just goes on and on. Okay, that is why you can see light for quite a long distance, even from distant stars and other things, because again it is just empty space, so that is why it's able to travel really fast. Okay, that's why you can see things light with different colors and other things from distant planets and other things, though they are emitted some other even things light which are, that some of the planets would have died out, but still the light you can see about 3.4 billion light years away. Still you can see some of the things which are just gone already, but the changes of the shape and the light is not there, exists, but the energy transmission that was done long time ago, which just gets transmitted over the media, and it's coming out of after 3 million years or something like that, 3 million light years or something like that. So now we understand what is the concept of light, what is the concept, how light looks like, and how generally a wave pattern looks like, how to use them in a kind of transmission, and how to create circuitry for memory circuitry, board circuitry, and other things for a parallel processing of light and things like that. Okay, how to storage light storage, how you can do, and those kind of things. So first thing you have to know is the range of 400 700 nanometers. That is the kind of uh, you know uh, range, and frequency is going to be around terahertz. So you can usually create some kind of terahertz frequency on which you can just design a computer or something like that. But it depends on how you're going to do all the technical work for that, and how you going to assemble as a kind of like a capacitor circuit. Then you have to design the inductive circuit for the light. So you have to use capacitor circuit, resistive circuit also for the light. And what kind of material choice you can, sometimes it might be polarized crystal, which you can use for as a resistive as an inductor kind of element. And so resistor also, it's another one. So how the circuit complexity is going to be quite difficult as for designing any kind of multiprocessing system or map, a computer chip or something like that. So those kind of things are going to be beyond the scope. How you organize those things, how to create LCR circuits out of it, those things, and how you can create gates out of it for switching on, switching off, those kind of things are all beyond the scope of this lecture, or kind of introduction kind of thing. So just to give a gist of what is light and how it behaves, and why, how a light looks like when it goes transmit in the media, what is the wavelength, why light transmits extremely, because it's got a shorter wavelength, and amplitude is also shorter, and frequency is also much higher. That is why it's able to travel quite extremely long distances. Okay, these are the basic concept you have to understand. And secondly, it is just energy media kind of thing. That is why it is able to transfer extremely fast. Okay, they also have inductive effect, capacitor effect, and resistive effect in the media, any kind of media you choose. Okay, so these things, and you can form circuits also out of electrical circuits, or photonic circuits out of these kind of things. Okay, but no one has done any kind of photodiode and all is there, but ordinary, the photodiodes are already available. So if you they do energy trap of photodiode from the sun, it comes in, they have photodiodes, they trap energy as a kind of capacitor kind of thing, and trap energy, convert it to some kind of form of energy as an electrical circuit or something like that. It's possible, and they are doing it already. Part of it is, that is a capacitive kind of. So photodiode is basically, it's an energy capacity kind of thing. So there are other diodes which you can design, so trapping into different kinds of elements and things like that. Okay, so we just wanted to show you how photons can be used also in electrical circuitry and other things. Okay, and how we can do mathematical calculations based on those kind of things. Okay, that is all for today about light and LCR circuits. The last time we saw about LCR, how to control light and what kind of inductive effect and other things you can have, how we can trap light and store it as a kind of energy, as a capacitor kind of circuit. So basic photonic cells are all kind of capacitor kind of circuit, okay, and they store energy just to trap photons and produce electricity energy as a energy storage. Usually when you trap light and store it in some kind of form, it is going to stored in the form of electrical energy or charge energy. They don't usually store it as a kind of direct light kind of thing, but usually they store it in a different form, which is going to be using electronic vibrations or something like that, okay, or capacitor kind of thing. Okay, that is all for today about light and other electronic circuitry.